So today we are going to be looking at a pattern in algebra, and this is a simple pattern, and we are going to come up with an algebraical rule for this pattern. But in order to understand, or in order to get the pattern, we have to understand where it comes from. And you'll notice here that we have 3 questions that we are going to be looking at once we are done figuring out the rule for this algebraic pattern. The first question is, how many sticks are in the next diagram? Then we have, how many sticks are in the 20th diagram? And then write an algebraical sentence to describe this system. So if you look here, I have squares. I have 1 square, I have 2 squares, and I have 3 squares. So, with these squares, I have created a table. And in this table, on the left side, you will see that I have the number of squares. 1, 2, and 3. Now on the right side, I have the number of matches, which is 4, 7, and 10. So with that, we are going to look at different ways we can find this pattern. So if you look at this 4, 7, and 10, you will notice that from 4 to 7, we are adding 3. And then from 7 to 10, we are adding another 3. So one way of finding this pattern is 4 plus 3 gives us 7. 7 plus 3 gives us 10. The only problem with this type of pattern, if you remember in the question, we want to know how many sticks are in the 20th diagram. Well, in order to find out how many are in the 20th diagram, we would need to know what's in the 19th, the 18th, the 17th, and so on and so forth before we could ever even get to the 20th diagram. So we would have to do plus 3, plus 3, plus 3. So instead of doing this, there's a simpler way to go about finding out the 20th diagram. I'm going to show you a different pattern that we can use to jump straight into the 20th diagram. So, with this algebraic equation or rule that I'm about to show you, it benefits the rule that we can use to learn to get our answer. So we wouldn't have to know what the 19th and the 18th and the 17th were beforehand. We can just jump straight into it. So let's look at 4, 7, and 10. Now if you notice here, a rule that they use to get 4 is 3 plus 1. Now where did I get this 3 plus 1? Let's look back at our squares. You will notice that each square has 1 match and 3 sides or 3 sticks, okay? So 1 match and there are 3 sticks. 1, 2, and 3. So this is where the 3 plus 1 comes from. We are always going to have 1 match and 3 sticks. So you look at the 2, and it would be 3 plus 3 plus 1. So the way that we draw this out is we look at our 2 squares over here. I'm going to change up the color so you can see the different sticks. So we have our 1 match, and then we have our first 3 sticks, and now we have a new set of 3 sticks. 1, 2, and 3. And then our 1 match. So 3 plus 3 plus our 1 match. Now we need to look at our 3 squares. And right here we have 3 plus 3 plus 3 plus 1. And you will see, let's erase this and I'll change it to the color so you can see the rule, or the pattern, we have our 1 match, And then the 3 sticks, 1, 2, and 3. The first 3, the second 3, and then now we have our new set of 3. So there's actually an even easier way to abbreviate this rule. So first, we want to look at the 3 plus 1. And this, another way of saying this is one group of 3 plus 1. So we have one group of the 3 plus 1. And then you will notice here, we have the 2 groups. So 2 groups of the 3 plus 1. Notice there's a bit of some multiplication going on right now. So here for the 3 squares, we have 3 groups of 3 plus 1. So now we can make our own rule of numbers that, now we can see that this way that we've written it down, the 3 groups, the 2 groups, and the 1 groups of 3 plus 1, can be written in a form of multiplication. So let's go ahead and let's take this off. And you will see that we have 1, this 1, times the 3, plus the 1. So you'll notice we're going by the number of squares when we're doing it. Remember we said one group of 3 plus 1, then the 2 groups of 3 plus 1. So here's the multiplication written form of it. 2 times 3 plus 1, and then we have 3 times 3 plus 1. The rule here is linking a pattern to the number of groups of 3 there are and the number of squares. See? So, with that, we now can make our own rule numbers that makes the number of squares. X is 3 plus 1. So let's go back here. How many sticks are in the next diagram? Which would be 4, right? So if you look at this chart that I have here, the next diagram would be 4. So we know that the next number of sticks is 13. Well, how many sticks are in the 20th diagram? Well, we would write out our new rule that we have created. 3 times 20 plus 1 would equal 61. So see how we just jumped straight into the 20th diagram by using this algebraic rule that we have created? So now it says, write an algebraic sentence to describe this system. Well, we first want to say that the number of matches, so M, equals 3 times the number of squares plus 1. And this is the way we have used to find out the algebraical pattern rule that we have created here today. So I have here 2 different word problems that we are going to be looking at today. And with these word problems, I am going to show you different methods that we can use in order to solve the problems. So let's look at the first word problem. The first one we have, William and Sally put 160 marbles into a jar. William put in 83 of the marbles. how many marbles did Sally put in? So let's look at what the problem is asking us. It wants to know how many marbles. So from this question, we know that we are going to need to subtract. So how many marbles, and it wants to know, it wants to know about Sally. How many did she put in? So let's look at the rest of the, let's go back and look at this part of the problem. So we know that William and Sally put in 160 of the marbles. So that's our total that we have. And we know that 83 of the marbles belong to William. So now a type of method that we can use to figure out what this problem is called separate. And it looks like this. This is the result. This is the start. And this right here is the change. Now looking at our problem, we know that we started off with 160 marbles. So we want to write 160 into our start circle. Then we know that the change is that 83 of them belong to William. So we're going to put our 83 right here. But we don't know is what the result is. So we want to put a question mark into this circle. And the reason why we know that we are going to use this diagram, the separate diagram, to figure out this type of word problem is because we know that we're subtracting. So you're going to use this diagram when you are subtracting. So the problem is going to end up looking like this. X, which is the result, we don't know, plus we do know that William has 83, and with the X plus the 83, we get the result of 160 or 160 marbles. So let's look at our strip diagrams for using this method. We have here 83 marbles. And then we have here the unknown, which is our X. And down here for this strip diagram, we have a total of 160. So now we looked at the separate diagram in helping us to figure out how to find the result for this word problem. Let's look at our second word problem. This one says, Henry and Cindy have 150 marbles in a jar. 86 of the marbles are Henry's. How many marbles belong to Cindy? So we want to know how many marbles that they belong to Cindy. So the word how many marble, or the words how many marbles, tells us that we are going to subtract. So we know that Cindy and Henry put in a total of 150 marbles into the jar. But out of this 150, we know that 86 of them belong to Henry. So we want to know about Cindy. Okay? Now, a model that we can use in order to figure out this subtraction word problem is what we call part, and whole. And this diagram looks like this. It's a square with 3 boxes inside of it. This box is one part, this other box is another part, and then down here we have our whole. Okay, so one part of this equation, or this word problem, I mean, is 86. We know that 86 of the marbles belong to Henry. The other part of the equation is the number of marbles that belong to Cindy. But we don't know how many marbles belong to Cindy, so we are going to put an X or a question mark right here. Now we know that the whole amount of marbles is 150 marbles because that's how many Henry and Cindy put in the jar together. So we're going to put 150 into here. So this, based off the subtraction, we know that we can use part, whole in order to find out the result for this problem. Let's look at our strip diagrams for this problem. From here to here, we know that we have 86 marbles. But from here to here, where's this? We have X, because that's the unknown. We don't know how many marbles Cindy put in. We're trying to figure that out. And then for this strip diagram, this is our whole. And we know that Henry and Cindy put in 150 of those marbles into the jar. So I have shown you 2 methods of figuring out word problems. We looked at the separate method, and we have looked at the part, whole method in figuring out our word problems.